This is an AIMPT 2015 question basing on moment of inertia. Problem is like this. Three identical spherical shells, each of mass m radius r, are placed as shown. Moment of inertia of the system about an axis xx dash. This is the axis that he is talking about, right? So first of all, I shall know the formula for the moment of inertia of a spherical shell. About an axis passing to center and perpendicular to the plane. This formula I shall know is 2 by 3 mr square, where m is the mass of the spherical shell, r is the radius of the spherical shell. This formula can be derived based on integration, or you can remember basic formula. If you notice, for this spherical shell, that axis is there. But for the other two spherical shells, look at this spherical shell. Axis passing to the edge. That means if I call this as 1, 2, 3, this becomes I1, moment of inertia of the first shell. For the second shell, if I have to draw the same diagram, this is not the axis, rather this is the axis. This is whatever I2 is, which is parallel to this, which is IG, passing to center of gravity. Distance between them is nothing but the radius of that spherical shell. So I can use the parallel axis theorem, which based on which we can say I2 equal to IG plus mr square. This is a parallel axis theorem. Ig is nothing but this much, 2 by 3 mr square plus m into distance between two parallel axes square, mr square. So this is going to be 5 by 3 mr square. That's also even similar to the case of I3, because for this and this axis is passing to the edge. So the total moment of inertia of the system is I1 plus I2 plus I3. How much is that? I1 is 2 by 3 mr square. I2 is 5 by 3 mr square. I3 is also 5 by 3 mr square. So if I have taken mr square by 3 common, 2 plus 5 plus 5, that is 10 plus 2, 12 mr square by 3, that is 4 mr square. So moment of inertia of that system is 4 mr square. That's how we solve the problem. So the most important thing while solving this problem is, I shall know the moment of inertia of a spherical shell about an axis passing to center perpendicular to the plane as 2 by 3 mr square. And I shall know that how do I find the moment of inertia of a spherical shell passing to the passing to the edge of that shell, like this at these points, using parallel axis theorem. I equal to Ig plus mr square. Ig is already we have derived, plus r is the distance between the two parallel axes. Upon simplifying, you will get this answer, 4 mr square. So we solve the problem where r is the radius of that shell. Thank you for watching.